begin. Hello. Formal beginning of class. Because I started the
Hello.
OBS recording.
Hello, YouTube.
Hi, YouTube.
Remember to smash that like button and subscribe and hit the bell for all your... I don't even think the bell does anything. I remember I was like, there was one channel where I was like, I want to get notifications when this channel uploads anything. There's nothing happened. It's just like, I see unrecommended that they uploaded, and I was like, okay, nice fucking notification, bro.
I think the bell does like email notifications or some shit like
It
that.
doesn't, I'm telling you. It does not.
I think you have to turn on them. Like you can either get email notifications or like notifications through the app on mobile. I think
you
you
have to like go into like some setting and be like, hey, the bell means something.
Yeah. It's really stupid, but I think so. Yeah.
Yeah, but I felt it's just like, oh, the bell is just like, it's a nice little bell.
You know,
Alright.
it's fine.
You could at least have like added a sound to it, so like you can tap it and get a little bell sound.
Yeah, why didn't they juice the bell, man?
Least.
Hit the bell, fireworks go off.
Yeah, please.
Yeah.
Alright, so this is where we left off last time. I'm gonna go a little quick just recap of what we did last time, since the YouTube didn't go so well. We didn't do that. We honestly didn't do all that much, so I'm thinking like it won't really take that long. One thing we did was the decal here. Decal on the player.
You're not screen sharing.
Fuck! Thank you for reminding me. I'm sorry I yelled.
No problem.
Okay, so we added a little decal component. Go away. There you go. We added a little decal component to the car. Made it all big. All biggy. And then we made a little decal material here. So I made a texture that looks like this. Looks like this right here. And then I made a decal material that is of material domain deferred decal, because that's what you need to do for it to be on a decal. You also need to make it translucent. So I just fed this vector parameter or color parameter into base color and emissive, so it shows up in shadows, and then I just hit the alpha from the texture sampler. Is hit the alpha from the texture sample is fed into opacity, so the texture is really only doing opacity, it's not doing anything else.
Yeah, I got a quick question. I tried to take in a arrow picture, so just a white arrow on a black background. Wilhelm, could you mute? Okay. Yeah, so just a white arrow on a black background and replace your picture with that. But it just made the entire sphere white. It didn't cut off the black parts or anything like that. And then when I tried to put it on the game object, the surface just became a complete white rectangle or something.
Yes. So the difference here is that it might look like it's a black background here, but if I actually go to the texture, you can see that there's not black; it's just transparent. So there's no alpha in this part here.
Yeah.
So if you made an arrow that's just like a white arrow on a black background, that means that the background was black, but the alpha was still 1.
So the black background counted as 1.
Yes, for alpha. So what you could have done instead is you just put it in red instead. So instead of doing alpha, we sampled the opacity from the red color. Because in the white part, red is gonna be 1, because it's RGB 1 is white. While in the black part, R is gonna be 0 because then it's black and there's no color at all.
All right then.
So you could have used sample from R in that case. And as you can see, in my case, it works as well. If I... Hello? Oh, there it is. Why does it take like 5 fucking minutes for it to show up?
Render.
It's like offline rendering. Yeah. Yeah, you can see it still works. It looks a little bit rough. But yeah, so the color in the black part is actually black as well in my texture. It's just it's black with an alpha of 0. So even though I sample from red, it still works because the color is still black. It's just it happens to be black with an alpha of 0. So it kind of works, but it just get a little bit rough. I actually don't know, maybe compression or something. So yeah, if you want, we could have done this texture just white on black and then use red as the opacity, but yeah, both ways are fine.
Okay.
Yeah,
Thanks.
that's why it didn't work for you.
All right. Thank you.
No worries. All right, so next, to change the color of the decal in event possessed, we create a dynamic material instance. So unlike in Unity, we can't just go in and change these values raw, like these parameters here. Even though these are made to be changed, we can't change them on just the material itself. We can't do that. To change these values in runtime, we have to create something called a dynamic instance. So we have to do a create dynamic material instance, and this will create a new instance of that material. So it will just take this parent material here, which I just fed in the arrow decal, and then we'll create a new instance of this material. So it's not going to be the same, it's going to be a new instance of it. And on this new instance, we actually can change parameters. So here you can see I can call this set vector parameter value because it is a dynamic instance. So dynamic meaning it can be changed in runtime. And then we have to make sure we also set the material here. So I reset the material on the decal to be our new dynamic instance. So a dynamic instance, you can see it is a material. It's just like sort of a runtime created material with some extra cool ass features. And then we set the color here. So we set the color of this circle color. We do the select, which chooses very nice node. It just chooses option 0 or option 1 depending on what this index is. And we can also feed in a bool or an enum. Very cool, very useful. All right, any questions on this?
So you can't access like material instances through code. It has to be like a dynamic material instance.
I don't know. Let's see. I'm pretty sure that
We did
those...
materials through the code in our decal, but yes, an instance of it. But isn't that what you want? Like you get the material, then we created an instance of that material to have the color change on the instance and not the actual material.
Yeah, but I'm wondering what the difference between a dynamic material instance and a material instance is, because like a material instance in Unity terms would be the material and the like. That's how I picture it. But what's the dynamic material instance?
That it's gonna change. That it's changeable.
Yeah.
Okay.
So I don't know exactly how it's implemented in code. I'm pretty sure that regular instances are more performant. So since they're not expecting a change, they can be sort of made to be faster. Like you can sort of const stuff in them.
Yeah.
So that's why, like in Unity, stuff is dynamic by default. You can change whatever you want to. But in Unreal, they are sort of constant by default, so they're faster, more performant. And to actually be able to change something, you have to make it a dynamic material instance, which means like, okay, it won't be constant, it will be a little bit less performant, but you can actually change all of the vector parameters in it.
Right. So yeah. Okay. So maybe like a property block or something in Unity is like the dynamic material instance then.
I'm assuming like in Unity, because you have like every time you like create start the game, it like instantiates it's a material instance per object. So you can access like shared material to change the actual like base material. But then if you change the material itself, then you change just the objects. So I guess that's a kind of similar thing.
Yeah,
probably.
I think if you're looking for the Unity analogy, it is materials versus shared materials.
Okay, cool. Yeah.
But it is handled like fundamentally different. They don't have the same idea of what materials are. So there isn't really a direct comparison, but I think that's the closest one.
Yeah, that makes sense. Thanks.
Yeah. It said in the documentation that like a material instance or dynamic material instance is like super cheap, and you can change it like basically how many times you want without almost any performance input. So
Well, that sounds like
that
a
was
proper
a good.
concept.
Yeah. So I think it's somewhere in between there, maybe.
Yeah. I mean, in the end, it's the same. I mean, in the end, they both use DirectX, I imagine. So, I mean, deep down, it's the same codes, but they're just implemented in different ways. So I don't know. I haven't delved much into the rendering code of Unreal, so can't tell you for certain. But yeah, it's the way it is. Oops.
Not to stay on this topic for too long, but the way Unity handles this, and you guys, if you've had to like teach beginners, or if you remember like when you were starting to learn Unity, like a very, very common error that people make is creating like a million instances of the same material because they want to like lerp a color or something. And it seems like you can't really make that mistake in Unreal, right? It's kind of protecting you against that. So, this is a better way, I think, honestly.
Yeah. They're much more. They're always tending more towards performance in Unreal, for sure. Always making the most.
We managed. Oh, sorry. Yeah.
Always making like the most performant option defaults, and then you have to like opt into something else.
Yeah, but we created our dynamic material instance every time we overlapped the hitbox.
Oh.
And then we of course refactor it. But I mean, you could also create a million instances if you put it in the wrong place.
Yeah. There's always.
I mean, but I don't know how the garbage collection would work for that. Maybe it doesn't matter.
I mean, there's just a garbage collector that goes in every second or so, I think, and it scoops up your objects that have no references.
Okay, cool.
It's like a more stupid C# garbage collector. All right. So that's that part. Next, we did the widgets. So we did 2 widgets. We did the actual Hud widgets, which is like this whole screen covering thing. You can see here it says, "This is Hud," and it says lighting needs to. Let's fucking rebuild lighting. Let's just do this. Build lighting only. Get into the habit of doing this. If you see the red message, just build lighting. It's not hard. It's going to build and then do build lighting only. Takes like 5 seconds. There we go. It's done. So now we don't have a message, and it looks a little bit nicer. Yeah, so we had this nice like "This is HUD" over there, which is pretty cool. So that's the whole HUD widget, which is sort of a container for everything else we're gonna add. And it looks like this. Very Spartan. And then we also made the status widgets, the one we have here. So we also have like the player status widgets. And we instantiate one of these for each of the players. And they get added into this little status box, horizontal box here. But since we want to have this, we want to be able to access these from code, because we want to be able to sort of set the boost percentage and stuff like that. we made code base widgets. So the base class here, if you look at the parent class, it says raise player status widgets, and that's a code class that we made. And let's see, I mean, it's not very complicated. Let's just go look at it. Raise, what was it called? Player status widget. Raise player status widget. I guess I haven't remade for enough time. I haven't. Okay. I'm sorry. I'll just have to go look at it. Raise source, raise widgets. There it is. Looks C++ empty. There we go. So it's like nothing in here. So we have to override from user widgets. That's important. That's what we need to have to be able to even create widgets in Blueprint. So we just override from that, and then I add this little code function that we can call set boost percent. So we can call this function to interact with the widget in Blueprint. Even though we have no reference to anything of like a status bar or a progress bar or anything, like we don't have access to anything like that. What we just do is we just call this function. So we push data into the widget here. And then we just make sure that we implement that function in the widget blueprint. And in the widget blueprint, we can actually, handle this. So we can, we set the percentage of the progress bar and so on. And do whatever bells and whistles we want to do. If we want to play some animation or something, we can just do that here. So this is a very nice, easy, simple way of interacting with widgets from code. Is to make a base version, and then adding functions, adding variables if you want to have variables, whatever you want to be able to access from code, you can just sort of do that in the base class. And similarly, we also did the same thing for the HUD. So for the HUD, which is the big old wanker, we wanted just to have some way of adding a player status widget from code. So when a car spawns, it wants to be able to add one of these widgets and get a reference to it. So I want to add it, get a reference to it, so that later on, when I'm boosting, I can, call that set boost percentage function. That's all I want to do. So similarly, I created a blueprint implementable event. Add player status widgets, and it just returns that base pointer to this raise player status widgets. And just the same as before, I just make sure to override that. In this case, it's not a custom event; it's a function. They're basically the same thing. Only functions have return values. Where I just create this blueprint version of the widget. So in Blueprint, I can create the blueprint version. This VBP player status, blah, blah, blah. We could have perhaps done this from code as well. Maybe have like a variable that's like a T subclass off or something. We could have probably done this in code if we really, really wanted to. But it's fine. I think this is cleaner, honestly. So we create the widget, we add it to the horizontal box, and then we just return it. And since this VBP player status is a derivative of this raise player status widget, which is the return value, we can just return it, and it will cast it to the parent pointer. I mean, standard C casting rules. What's this? No. Yeah. Make sense? I recommend
I think
always.
so. Yes, sir. I said I think so. Yeah.
Okay. I recommend always creating a code version of most widgets. It's always good to have. Like, it's makes stuff so much easier. It's okay if they're Spartan, even if they have like one function. That's still nice. Just so you don't have to be like, some code Because the other way would be to like put that code in like, fuck this. Go away. There we go. Sometimes like the attachment widget gets stuck on screen. The other way to do it would be like in tick in like BP race car to like get the blueprint widget and set the progress bar or something. And I mean, I personally don't like this a lot because it means that we have like code in 2 places. Sure, if it's like play audio or play particle effect or stuff like that, that's sort of expected to be in blueprints. Like some code belongs in blueprints, and you know, particle effects and audio, I would say, belongs in blueprints. But stuff like just like setting the progress bar on our widgets, I mean, that's a little bit more unclear if that belongs in blueprints or belongs in code. So that's nice if that's just in code where all of the other logic for boost is. I don't know. That's just my opinion. Of course, yours might differ, and that's fine. You do you. But yeah, that would be the other option. Would be to like tick in blueprint, get a reference to the blueprint widgets, and do stuff. But yeah, I think it's nice to have widgets references in code because they're kind of gameplay dependent. Cool. And just to finish it up, in the game mode, here in the game mode is where we actually create the HUD. So in start play of the game mode, we create the HUD widget. And we just had like a tsap class off for the race HUD widgets to get the blueprint version. So we just create it and we add it to the viewport. Easy peasy. So later in the race car, we can get the game mode. So we just do gameplay statics, get game mode. We get it. Cast it to our own like base class for this race game. And then we have direct access to the HUD widgets, which means we can call this add player status widget. So the race car adds the status widgets, saves it to a variable. Right here, baby. So you save it. I should mention, by the way, always make UObject pointers, always make those UProperty. Because we just talked about the garbage collector. Regular pointers do not count as references to the garbage collector. So if you just have a plain pointer and nothing else in the game is referencing this UObject, it will get garbage collected. Because it won't recognize that you are sort of holding a reference to that UObject. You need to make it a UProperty because then it will actually register that, oh, okay, something is holding a reference to this UObject, don't garbage collect it. It's okay if you don't remember it because it's very rare that you're just holding a UObject with no other references in code, but it's good to know that if for some reason all of a sudden your UObjects become garbage, make sure that your pointers are UProperties. Otherwise they might become garbage at random times because the garbage collector just comes in, scoops them up.
I've just been making everything a UProperty. Is there a big performance hit to doing that?
I don't know. Don't think so. Shrug emoji. It's probably some performance hit, but I don't know how big it is.
Is there any reason to like if say there was a performance hit to using your properties, do you know like if many people mix C++ smart pointers in if they want to do like reference counting without hitting the garbage collector type thing?
Never for UObjects. Never ever use.
Oh yeah, never mix the two. Obviously, I mean like if you were gonna, if say you didn't want a UProperty because you were scared of what it might do, Is there any advantage to using more kind of standard tools alongside the garbage collection system in Unreal, or will you just cause problems, or is it not worth it, or what are your thoughts?
The only time where it's okay is when it's not an U object and you have to allocate something. So it is used. We could probably go to like, I don't know, probably the game viewport client maybe. Maybe here we can find something like T shared. Of course, they never used STD. Yeah, here for example. So here you can see they use its T shared pointer. So this is S viewport, and that's Slate. So S stands for Slate. And I was talking briefly last time about Slate. Slate is the base widget system that Unreal uses. It's the thing that creates the window. It's the thing that handles input bubbling. It's the thing that handles widgets, widget alignments. Everything that has to do with widgets is Slate. It's just that the Unity Unreal widget system, this system here, is sort of just a nice interface to work with Slate. In the end, all of these widgets are going to be converted to Slate widgets. So that's the base widget system of Unreal. However, those do not use the uProperty system. They are not inheriting from uProperty. From uObject. They are just straight up classes, which means they're not garbage collected. Which means that you usually don't pass these around as your straight pointers, because that's scary. So instead you use this T-shared pointer. And of course, Unreal has made their own, like never use STD for anything. I doubt you can include STD, but you might be able to, but never do that. Always use whatever Unreal is providing you. So in this case, yes, T-shared pointer is used. Some other times, in sparse situations, T-shared, here's T-shared ref as well, which is just a shared reference instead of a shared pointer. Some other times when you're creating your straight, like here, here's creating like an iGame layer manager. I have no idea what that is. Probably not the object. So here it also uses T-shared pointer. So yeah, it sort of depends on what you're doing. It's rare to do something where you have to use T-shared pointer. Usually that's when you're doing something engine related, where you're for some reason are instantiating structs or classes that aren't the objects for something weird. But yeah, so rarely. I guess that's the answer to your question, is rarely. But it's
a great answer, thanks.
I
learned a lot from digging down. This is good. Thank you.
Yeah.
I can't be the only one that got super bothered by the complete lack of consistency in that file. The code consistency was completely off. Like sometimes they have spaces before brackets, and sometimes they don't.
Oh, well, yeah, but that's because there's like probably 100 people that worked in this file.
Yeah, the file's probably 30 years and like 4,000 revisions old.
Yeah, this is probably something that Sweeney wrote like when he was a young child making like Unreal Tournament 2 or something. Yeah.
There's even like there's comments over functions that say don't use this function. It's like, well, fucking take it out then.
Yeah, there's a bunch of here's like UE deprecated, so there's a bunch of like deprecated stuff that's still in everywhere. Well, I mean, they're so scared of changing anything because since the Unreal has become such a huge engine nowadays, like it's used in so many different games, so many different projects, in different fields. There's like if they remove a function, like a lot of programs will just stop working. They will be stop compiling, and so they are quite very scared to actually remove anything. That's why there's like this UE deprecated since 4.24, and they haven't gone about removing them yet. So it's scary. I would not want to work on Unreal Engine. It seems fucking rough. Cool. What we're doing? Oh yeah. So in race car, we got a reference to this race player status widgets. We got a reference to that bad boy from the Hud Widgets. Get it? And then we can just call this set boost percent. So we can update the widgets to show how much boost time we have left. Ain't that nice?
Yes.
Very nice.
I think it's nice.
Thank you.
Very, very nice.
Freaking epic.
Oh, really?
It's
So?
still hard coded, but you know. that's
No,
not
it's not.
crazy.
It will always be 2. It's like it's a constant.
But that's the definition of hard coded.
You're the definition of hard code.
Yeah, I'm super.
Yeah,
Wait,
get
no,
fucked.
let's not go. No.
Get
Yeah,
fucked.
keep going.
Well, wait, just quick question. Well, I was trying to use overlap function to see if a car runs into the object that has it. We went through that one a few days ago. The whole thing not compiling until like we started several times.
Mhm.
Yeah. So this time when the car ran over, I was trying to see if I could get the car's decal component. In which case I tried like a similar where I could basically cast decal component, but it didn't work for me. Is that how you're supposed to do it?
So you had a reference to the player and you wanted to get a decal component.
Yeah. I managed to get the race car script with the cast, but I didn't get the decal component.
Yeah. So if you have the player,
Mm.
so here's a pointer, player, and you want to get a component out of it, then you call player, find components by class.
Find component by class.
Yeah, and then in the crocodile mouth, you just type decal component. There you go.
If I have the decal component, can I do the same if I want to find the race car instead?
Then you would do, so if I had a decal component,
Mhm.
then you would do, and actually, can someone help me here? What would you do? Okay, first step, how do I get which actor the decal is attached to?
Find component by class.
Get owner?
There we go, get owner. Because the owner is, the actor is not a component. So decal get owner. I don't think, I think it's not working because I haven't included the components. Okay, so I get the owner, and then how to get the race car of that? What would I do then?
Is there like a generic version of get owner, or
Would you cast it?
There might be a generic version of get owner. I don't know. I don't think so. But the other version, if just is or the other way of doing it is just cast. So we will cast. Whoops, to a race car. There we go. So that's how we would get the race car back from the decal. You get the owner. So unlike in Unity, where it's just like everything is components and it's hard to make something that's not a component, in Unreal there's a very hard difference between an actor and a component. They are two completely different things, and they, you know, a component is always attached to an actor. An actor always has components on attached to it.
So if you can bring up the race car blueprint real quick. So that then does that mean that BP race car at the top is the actor, or?
Yes.
Okay, yeah, the BP race car at top is the actor, and those below it are the components.
Exactly. So this is the components.
Yes.
Cool.
Side note, you can also use generic. I just looked it up. So
there's
that's a
generic?
possibility. Yeah, apparently.
Is this like get the owner and crocodile mouths?
Yep.
Oh, you son of a bitch! This is awesome. Okay, I will use this.
Right? It's
Very
super
cool.
nice.
Very cool.
Yeah, I didn't know about that. That's going to save seconds of typing.
That's gonna
Thank
yeah,
you.
literal seconds of my life.
So useful, right?
I will use that time to like personally thank you every time. I'll be writing like I did it again. Thank you. I saved some seconds.
It's a
that's
lot
cool.
more readable too, honestly.
That's very nice. All right, cool. Let's take a 10-minute break. So I'll be let's start again at 11. So a little bit more than 10 minutes. So see you guys very soon.
See ya.
See ya.